diagrammatic tools. Tools here means methods. In this, we try to explain mathematical relationship or economic relationship with the help of a diagram. A diagram is a simple thing. We have x-axis, we have y-axis that you have studied up in class 9th or class 10. When we take a point here, this point shows relation between x and y. You may represent anything on x, anything on y. The two must be related in one way or the other. So that shows at this point, this much is x and this much is y. Like this, there can be several points. Join them and this becomes a curve. So what is a curve? Curve is a locus of points. Points को जोड़कर बनाया गया. It can have any shape. Here I have just drawn one shape. It can have many shapes. First, let us try. What are these shapes? I'll take 4 shapes at present which are more frequently used in economics. We have x-axis, y-axis. One shape is this. Another shape is this. Then one shape is this. And another shape is this. In mathematics, you call them hyperbolas also. But in economics, we simply call it curves. It may be a straight line, it may not be a straight line. A straight line is, but what do we find? These both are downward sloping, coming from above and to downwards, say this way. And these are upward sloping. How do we say that these are upward sloping and these are downward sloping? So in this case, we take origin. From origin, they are going above. And in this case, from y-axis to x-axis. These are like that. Now, what exactly is the difference between these 4 figures? We call such figure as convex. And we call such figure as concave. Now, what difference do you find between convex and concave? Suppose you are standing here and watching this figure. Then this figure is bent towards you. आपकी तरफ झुकी हुई है. You are standing here and watching this figure. This figure is bending away. It's going further. दूर जा रही है आपसे. तो अगर ये origin की तरफ झुकी हुई हो, bent towards origin, it is called convex. और अगर ये परे ऊपर की तरफ जा रही है, झुकी हुई, तो इसको हम बोलते हैं कॉनकेव. इसी तरीके से आप ये देखिए, ये एक्स एक्सिस की तरफ झुकी हुई है, वी कॉल इट कॉन्वेक्स एंड वी कॉल इट कॉनकेव. Now, what is the basic difference between the two? These two are downward sloping and these two are upward sloping. That is the difference. So, we have to make a distinction between two: convex, downward sloping, concave, downward sloping, convex, sorry, upward sloping, and concave, upward sloping. Okay. Besides this, you can have even straight line curves like this. This is upward sloping, this is downward sloping, and all that. But here we are talking about mainly about hyperbolas, or the curves which have so which are not straight lines. These are four types of curves which are normally used in economics. Okay, we make a distinction among these curves in another way. For that, we have to be familiar with another concept, and that concept is slope. Now, what is a slope? Suppose you move from this point A to this point B. When you move from A to B, what is happening? When you move from A to B, you are gaining X and you are losing Y. So when we talk of slope, we say how much we have gained in terms of X and how much we have lost in terms of Y. We take their ratio, delta Y axis divided by delta X axis. Normally, in economics, instead of writing delta Y axis or delta X axis, we normally write delta Y upon delta X. Now you see, what is delta Y? If I suppose I give you C here, then delta Y is AC. And suppose I CB, then this is delta X. So if I apply this, let us say, method here, then in this case, the slope will be equal to AC upon BC. Now we should be careful about one more thing here. Remember, AC is fall in Y. So it should normally be minus AC. And the answer should also come in minus. But remember, I'm going to tell you a very important thing about slope at this juncture. Although the value may be in minus, but when we compare slopes, we ignore this minus value. This is why in most of the studies of economics, although this has a minus value, but this minus value is ignored and sometimes even not used. So that you will learn as you make use of this diagram. I'm going to tell you another important thing about slope, which you are going mostly to use in class 12 rather than class 11. That slope is the value what we call marginal value. Our entire economics is based on marginal value. Now, we won't go into detail of this, but I'll just like to tell you the meaning of this. Suppose you're talking of a cricket player who in 10 innings have scored, let us say, 1000 runs. In 11 innings, he scored 1050. That means in one more inning, he has scored 50 more runs. So this 50 then becomes the marginal value. And this has a very important place in entire economic studies, marginal value. We won't talk much about this, but just keep in mind that slope is nothing but the marginal value. You have studied economic mathematics up to class 10. Let me tell you one more thing. You have studied derivatives. The first derivative, dy upon dx. If you are given an equation and you find the first derivative, it is same thing as marginal value, and marginal value is the same thing as slope. This is how mathematics is applied to economics. Okay, so this is these are four types of curves we have understood, and we have talked about slope. Let us talk about the behavior of slope on this. I'd like to draw this diagram again. Now I'm talking of behavior of slope. In this case, as you move from like this, slope falls, ignoring signs. We can even prove that, but proof is not necessary at this stage. In this case, as you move downwards, then slope goes up. In this case, in this case, as you move upwards, slope goes up. Now remember, this is convex, this is also convex. But there is a difference. This is downward sloping convex, this is upward sloping convex. So the behavior of slope is different in these cases. Similarly, in this case, slope comes down. Now remember, this is concave, that is also concave. But in case of downward sloping, slope goes up. In case of upward sloping, slope goes down. This is the behavior with these hyperbolas, what you can say. Then there are other curves. Suppose it is a straight line. Let me draw it again. It doesn't look like a straight line. Suppose this is a straight line. Now, as you move along the straight line, slope is constant. Whether you take at this point or this point or this point, slope is constant. Same is true about if it is an upward sloping straight line, slope is once again constant. There are other variations. If the curve is like this, slope is 0. If the curve is like this, straight line, upward sloping, then slope is infinite. We can prove that. All these things we can prove mathematically, but at this stage that proof is not necessary. Even you can make out your own proof. For example, suppose you move from A to B. What do you find? From A to B, delta y is 0 and delta x is positive. So if you take slope here as equal to delta y upon delta x, then what do you find? 0 upon whatever it is, the answer would be 0. Similarly here, delta x is 0 and you divide anything by 0, the answer will be infinity. So this is about the behavior of the slope. Then there is another part of this. It is equation. You are all familiar with the equation. A is equal to B. This is an equation. So what is the characteristic of the equation? Both the sides are equal. A is equal to B. Whatever is the value, if A is 10, B is also 10. That is an equation. But what we use in economics, what we called functional equation. Functional equation. Now, what is a functional equation? We write it like this. A is the function of, let us say, B. What does it mean? That what will be the value of A will depend on the value of B, and simultaneously the value of F. Suppose B is 2 and F is 3. Remember, another term used, I think you are familiar with that, this is constant. The value of F doesn't change. Then A will be 6. You can take another value. If B is 3, F remains 3, then A will be 9. So what will be the value of A will depend upon the value of B. Value of F is given, of course, but this is constant. This is called functional equation, where you can say A is the function of B. A is the function of B. Now the standard equation which is used in economics, it is y is equal to A plus B x. Now what this here, A, B are constants. So once again, value of y is dependent upon the value of x. Why don't we say that it is also dependent upon A and B? The value of A and B once given is given. It may be 2, it may be 3, it may be 4, but value of x can go on changing. Another form can be same, A minus Bx. Then still another form can be A, it can be B, Bx, simply Bx. Now, what is the difference? This value is true in case of upward sloping curves. Let us start it from here. Now, suppose there is another curve like this. Then this is the value of A. How do we say that this is the value of A if we take this curve? Suppose we take x is equal to 0. then bx is also equal to 0. Then at 0x, the value of y will be equal to a. So the y-intercept, we call it y-intercept, this is the value of a. This curve is true in case of downward sloping curve. Y is equal to a minus bx, because as you move downwards, the value of y go down. By how much? By this much. At 0, if we take it at 0, then this is a. Then this here a is 0. This is true because there is no a. If x is 0, then value of y is also 0. So these are some of the variations. These are some of the tools which you may use even in statistics, but you are going to use them extensively when you go to class 12. There you find that most of the students feel, let us say, handicapped when it comes to diagram. They try to memorize diagrams. But once you understand these things, then memorization of diagrams will not be required. I think this much is enough for this topic, and this is what you are required to study in class 11. Let us now move to our second part of the syllabus, that is Indian economic development.